So today, guys, we are going to evaluate the internal resistance of the galvanometer. It is around 135 ohms, as you can see. I will try to show you that number, the 135 ohms. Yeah, so it is 135 ohms. Yeah, so let's get started. So what do we need for today's experiment? We need galvanometer, we need DC power supply, we need voltmeter, and we need ammeter. So both of them are avometers, but I will adjust this one to be voltmeter and then adjust this one to be ammeter. And also I will need another voltmeter to check the voltage across the galvanometer. So the experiment, guys, is simple. What do we need to do? We need to connect this circuit that I will show you right now. The circuit would be resistance R here, connected in series with the galvanometer, and then connected in series with the power supply. So this is the circuit, as you can see. So this is R, this is the galvanometer, and we can call this VP, the power supply voltage. So now, as you can see, guys, all of them are connected in series. So what we will do right now, we will try to connect this circuit first, and then I will tell you what we should do. Okay, so let's connect everything in series. I will do that in front of you. Okay, so this should be the voltmeter, this should be the ammeter, so I will have it here. Here I have some banana cables to connect the circuit. So I will start from the power supply. This is the negative point of the power supply, and this is the positive point. So we'll start from the negative and then go. And then this is the resistance. The resistance that I choose here is around 4,000, maybe 4,700, but I will show you guys why I will start with this resistance first. Go to the resistance. As you can see, hopefully that's clear. Yeah, maybe I will try to adjust the camera so you can see everything clearly. Yeah, I believe that's clear now. Okay, and then go from the resistance to the galvanometer. Sorry, we need to have the negative connection right here, and then from the galvanometer we should go to the power supply. But what I will do, we need to know the current, so that's why I will connect this point right here from the galvanometer with the ammeter. And then from the ammeter I will have it right here, and then from the ammeter to the power supply. That's great. So we will connect this one right here. So that's great. Now what I will do, I will have voltmeter right here connected all the time to the power supply. So I will connect it right here and connect the other side right here. Now you can see that the two points here from the power supply are connected to the voltmeter. So that's great. Let's start the power supply, and then write down the voltage, which is VP. So I will write it down here for you guys. So this is VP. Hopefully it is clear and you can see it. Maybe I can make it a little bit closer, just zoom in. Yeah, so you can see here guys that we have 1.454. So VP is equal to 1.454 volt. This is the VP. This is the voltage from the power supply. I know that guys, some of you still didn't study the electric circuits, but I will try to explain that in details for you. And also we will go through the syllabus, through the course, as you know, and we will cover this topic soon, so don't worry about that. Okay. Now guys, what we will do, we will try to start the ammeter, and hopefully you can see the ammeter reading. So this is the ammeter reading. It should be, let's see. Hopefully you can see it. Okay, yeah. So this is the ammeter reading. What I will do right now, I will connect the whole circuit and see what do we have. So as you can see right here guys, we can see that the galvanometer reading is not max. So what we will try to do guys, we will try to change this resistance. So actually instead of this resistance, we should have used resistors box, but since we don't have a resistors box, what I did, I attempted to use different resistors, and the reason was to have the resistance that allow this galvanometer to have max reading. Yes, and this is the resistance guys right here. Yes, so it is 2 kilo ohm. We can measure it. It is around 2 kilo ohm, but I will measure it for you guys. So this resistance right here is still high. It won't give us the max reading that we are looking for. So I will adjust this galvanometer to read ohms, and then I will try to read it, and hopefully it's clear guys. I will double check. Yes, I think you can read this reading right here. Yeah, let's see. So here we have around 1.2 kilo ohms, and like this we have around 2.5 01, 2.5, 01. Yeah, so we have around 2.501. So this R, or this resistance, is 2.501 kilo ohms. So that's great. This is the resistance that will allow us to have max reading on this galvanometer. So I didn't go through the process of changing the resistors because that will take long time, and since we need to reduce the time, that's why, guys, I showed you the galvanometer reading with around like 4,000 ohms resistance, and then I will show you the reading after we have this resistance fixed here. So let's do that together. I will remove this resistance right here. So it is really high. I will show you that. It should be, yeah, 4.8 kilo ohm, which is 4,800 ohms. And actually we don't need it. It will not allow us to have max reading. It is important to have max reading here because that will allow us to evaluate the internal resistance of this galvanometer. And we will need it when we do part number 2 of today's experiment. Okay, so I will have this resistance right here. Yeah, you can see now we have max reading, guys. So we have max reading, and you can see that the ammeter here is showing us 0.52 milliampere. So we have 0.52 milliampere. The voltage across the power supply is 1.39, like around 1.4 volt. But let's write down 1.398 volt. Yeah, so I wrote that. That's great. And we wrote this value of the resistance, this one. Now, guys, what I will do, I will write down the current. So the current that we have here is 0.52 milliampere. So we have 0.52 milliampere. So that's great. This is the current. This is the current that we have. So this current flows in this circuit. Okay. Now, guys, what I will do, I will have this voltmeter. So I will change this ammeter to read voltage. Okay. So this will read voltage. And now what I will do, I will try to connect this to one of the galvanometer terminals, and the other one to the other side of the galvanometer terminal, and see what do we have. So actually this scale can be adjusted. I don't know if that works if we do that. Yes. So what we have, guys, here across the galvanometer, I will show you that. Yeah, so across the galvanometer. So what I did, I measured the voltage across the galvanometer. So what we have, as you can see right here, guys, hopefully it is clear also for you. I will try to adjust it. Maybe you can see it better. Okay. So we have 68.9. So we have 68.9 milliampere. Sorry, millivolt. So we are measuring the voltage across the galvanometer. So that's great. Yeah. So that's great. We have now the voltage across the galvanometer. Now guys, to figure out the resistance, what do we need to do? Actually, we need to divide this voltage right here by the current. I think guys, I sent you note that talks about Ohm's law. I don't know if you studied that, but Ohm's law telling us that the resistance is equal to voltage divided by current. R is equal to V divided by I. So what do you need to do, guys? You need to divide this value right here, 68.9 millivolt, divided by 0.52 milliampere, and see what do you have. Yeah, so this is everything, guys, about today's experiment. Once you divide the voltage by the current, you will figure out the value of the galvanometer resistance. So what I will do right now, guys, I will try to zoom in and show you these values. Maybe I can move. Maybe this is better, guys. I will show you these values. Yeah, so we have 68.7 millivolt. This is the voltage across the galvanometer. Here we have the current that flow in the circuit. So what do we have? We have 0.52 milliampere, and here we have the voltage across the power supply. Yes, and this is the resistance, guys, that we have. Actually, here we have two resistors connected in series. Yeah, I think you are familiar with that since you are done with lab number 2. So you know what does that mean if we connected resistors in series or in parallel. Yeah, so this is everything, guys, about part number 1 of today's experiment. Now let's move to part number 2. Okay, this is part 2, guys, of today's experiment, and in part 2 we will try to convert this galvanometer to be voltmeter and then use it to measure the voltage across these batteries, this one and that one. Yeah, and see if we have if we build like good voltmeter or not. So the circuit that we have here, guys, is the same circuit. I will draw that. Just there is one difference, and I will show you this difference as well. So we still have this resistance right here, and we have power supply, and we have the galvanometer, we have ammeter right here, and we have voltmeter connected across the power supply. So here we have R, and here we have VP. So this is the circuit that we have, guys. It is the same circuit. So we have the galvanometer here, ammeter, resistance, and the power supply. And I fixed here voltmeter to measure the voltage, make sure that the power supply voltage is accurate. So that's why I have voltmeter right here. Yeah, the same circuit. The only difference here, guys, is that I changed this resistance with 4,800 ohms. And why is that? I changed this, guys, to make our voltmeter read wide range of voltages. So let's check that, guys. I will show you how this this voltmeter that we built can read like wide range. Yeah, I choose this range to be like 2.5, something like this. So we changed this to be 4,800 ohms, and then I will increase the voltage here. Try to, so everything is connected. Okay, let's see here. Oops. I will increase the voltage, but I need to fix this indicator, the galvanometer indicator, to be on the max, which is 5 here. Okay. Yeah. So now, guys, as you can see, here we have the max, which is 5, and here we have the current that flow in the circuit, and here we have the applied voltage. This is V peak to peak, which is this one, V peak to peak. So now, guys, what I will do right now, since this voltmeter is working and can read maximum voltage 2.559 volt, so what I will do, I will remove this power supply and then try to use it to measure the voltage. So let's do that, guys. So to use it, guys, to measure voltage, what we will do, we need to have standard. So we need to have standard. So what is this standard, guys? We will try to change the voltage, decrease this voltage, and then record the power supply voltage and the galvanometer reading. And continue to do that. Maybe we can collect around 4 points, 4 data points. So 4 data points are enough. So let's do that, guys, together. Now, what do we have here? We have 2.556 volt, and the galvanometer reading is 5. So don't care about ammeter or microammeter, no. You can pick just this number. You are building a like calibration plot to figure out the voltage when you try to measure voltage across battery, for example. So don't worry about any units here. You can have 5. So 2.556 corresponding to 5. I will double check that we have exactly 5 here. So what I will do, I will increase the power supply voltage a little bit. Yes, a little bit. Yes, now we have exactly 5. So 2.59 volt and 5. You can write that down. And then, yeah, and hopefully that's clear, guys. I will, yes, zoom in a little bit so you can see both of them, the galvanometer reading and the voltmeter reading. Now I will decrease the voltage, go down to have around 2 volt now. Yes. So here we have 2.02 volt, and the galvanometer reading exactly is 3.9. So 3.9. So 3.9. So here we have 2.02 volt, and here we have 3.9. Now I will decrease it to be around 1.5 volt, or maybe 1.6. That's great. So here we have 1.6 volt, or 1.599. You can write down 1.6 volt. And here, guys, you can see that we have 3.1. So great. Now I will continue to decrease the voltage. So here we have 1.233. So 1.233 is corresponding to 2.4. So we have around 2.4. So 1.233 volt and 2.4 from the galvanometer. Now, guys, so you can see that we collected the voltage data and the galvanometer readings. So what do we need to do now, guys? We need to use this data, as I will show you. So you have the galvanometer reading, and you have the power supply reading here. We picked 4 data points. You can have them from the video. Watch the video twice or 3 times to collect this data. And what do we need to do now, guys? You need to plot this data. So the y-axis is voltage and the x-axis is the galvanometer reading. And what you will have, guys, you will have a line like this. So what do you need to do, guys? You need to use Excel and fit those 4 data points with a line, and then try to display the equation. So there is equation will appear like y is equal to something, x minus or plus something. Y is equal to something, x plus minus something. So you can use this equation to figure out the voltage, for example, that we will measure for these batteries. So I will show you that, guys. So what you will have for those batteries, you will have just the galvanometer reading, just the galvanometer reading. And what you will need to do, guys, you need to use this galvanometer reading and go to this equation and apply y is equal to something times x is plus minus something. Y here represents the voltage, the battery voltage. X here represents the galvanometer reading. So what I will give you the galvanometer reading, so you can use it here. I will start with battery number 1. But before that, what I will do, I will disconnect the power supply, so we don't need it, because we will use this galvanometer as a voltmeter now. Great. Just to don't confuse you, now we have this system. Actually, guys, also we don't care about the current, just we care about the galvanometer reading. So now what I will do, guys, I will try to measure the voltage across this battery and see what do we have. Oh, sorry. So this is positive. We need to change that. Yes, so this is the negative. Yeah, see what do we have, guys. So for this, guys, we have 2.6. This is the galvanometer reading, 2.6. So we have 2.6 for this small battery. I will write that down for you. So galvanometer reading. That for the small battery we have 2.6, and for the large battery, let's see what do we have. I will show you that. So for the large, sorry, this is the small one. We did that. Now we need to measure this for the large battery. So we have, so we have like around 3.1, around 3.1, guys. This is the galvanometer reading, 3.1. 3.1. So this is the galvanometer reading, guys. The galvanometer that we designed. So for the small battery we have 2.6. This is the galvanometer reading. And for the large battery we have 3.1. This is the galvanometer reading. And what you need to do, guys, you need to go to the equation that you will have when you plot those 4 data points, the power supply voltage and the galvanometer reading. And you need to fit it, as I mentioned, with a trend, and then display the equation. So you will have equations. So use this equation to figure out the voltage for these batteries. This is your standard here. This is your standard that you will use. Just you need to apply those numbers instead of X right here. So the 2.6 and 3.1. Okay, so now, guys, as you can see, we are done with part number 2. So we could manage to build a voltmeter, and also we could manage to use it to measure the volt for these batteries, as you can see. Okay, so we'll close this. Yeah, so this is part 2, guys. Part 2 is done. Now I will move to part number 3. Just to remind you guys, before you start part number 3, you need to know that the voltmeter simply is galvanometer connected in series with resistance, and this resistance should be a huge resistance to protect the galvanometer. If this resistance, for example, is very small, so what will happen, this galvanometer will be damaged. But that's why we choose this resistance to be huge resistance, like around 4,800 ohms. Yeah, so this is the voltmeter, guys, that we built. Huge resistance connected in series with a galvanometer. Yeah, and we use those terminals right here to measure the voltage for the 2 batteries, the small one and the large one. Also, guys, I would like to mention to this equation, so what do we have here in this equation? We have the resistance that is connected in case of converting the galvanometer to voltmeter. This is part number 3 from today's experiment, and in this part we will try to convert the galvanometer to work as a meter. So actually, guys, what we will do is the following. So we will try to connect a resistance in parallel with the galvanometer, and since the resistance of the galvanometer is 135 ohms, we need to choose this resistance to be kind of small, so the current can flow through it and avoid flowing through the galvanometer. So it will flow through the galvanometer, but not all of the current. Some of the current will flow through the galvanometer. So that's great. So this resistance should be small, and we will choose 10 ohms for that. And then guys, this ammeter that we built, galvanometer, connected in parallel with resistance, 10 ohms resistance, will be connected in series in this circuit with the ammeter and another resistance here. This resistance, guys, here is to protect the whole thing here, and of course protect the galvanometer. And we choose this resistance to be 1000. So this 1000 is inconsistent with the 10 ohms here and the resistance of the galvanometer. So this is the circuit, guys, that we will use to make sure that this ammeter that we will build here, that we will test here, is working accurately. And we will test this ammeter that we build with this ammeter right here, and we will see if we have the same values. Okay, so that's great. I connected the circuit, as you can see, guys. So we have resistance right here. This is the 10 ohms resistance. This is the galvanometer, and this resistance is connected in parallel with the galvanometer. Great. And then from the galvanometer we go to the ammeter right here, and from the ammeter right here we go through the 10,000 the 1000 ohms resistance. And from the resistance we go through the power supply, and of course the other side of the galvanometer is connected to the power supply, as you can see. The only difference, guys, we added voltmeter here, connected across the power supply to see how much voltage do we have. Great. So what we will do right now, guys, we will try to reduce the power supply voltage, and then we will write down the galvanometer reading and the ammeter reading. We need to have both of them. We need to have both of them. So let's do that, guys. We need to make a table like this, galvanometer. Yeah, you need to have a table like this, so you have the galvanometer reading and the ammeter reading, of course, in milliampere. So we will do like around 4 data points. Let's do that together, guys. So you can have the first data point. So the first data point is 5 here and 4.62 milliampere. So this is the first data point. Now, guys, we will reduce the power supply voltage to have the galvanometer, it should be, yeah, I will double check. Yes, so it is around 4. The reading on the galvanometer is 4, and the ammeter here gives me 3.61 milliampere. Hopefully that's clear, guys. So you can see this reading right here, 3.62 milliampere. Okay. Continue to reduce the voltage until we achieve 3 here. Go down, go down, go down. That's great. So we have 3 right now, as you can see right here, guys. So with this reading from the galvanometer, we have 2.72 milliampere from the ammeter. So 3 from the galvanometer, 2.72 milliampere from the ammeter. That's great. And then continue to reduce the power supply voltage until we have this galvanometer reading 2. So we have 2. So the corresponding reading from the ammeter is 1.73 milliampere. 1.73 milliampere. So I believe now, guys, you have a good set of data points. What do you need to do now, guys? You need to plot what do you need to do, guys, now? You need to plot this data. As you can see, you need to plot the current versus the galvanometer reading. So you need to have 2 and 1.7 and then 3 with the other corresponding current data, and etc., guys, until you finish the whole thing. And when you plot the whole data points, guys, you need to fit them with a straight line and then display the equation using Excel. This equation also, guys, will be like this. So y is equal to something times x plus minus something. Yeah, so now you can use this equation, guys, as a standard. I will write it down here. Y is equal to number times x plus minus number. Yeah, this is the equation, guys, that will appear when you display the equation for for this string, guys. So y will represent the current, x will represent the galvanometer reading. Now what I will do, guys, I will cover the ammeter display and try to have a random galvanometer reading, and then ask you to figure out the current using this equation that you will get. If you have any problem, guys, plotting this data or finding this equation, please, I encourage you to email me. The same thing is applied on the voltmeter portion. Yeah, so if you don't know how to plot the data from the voltmeter portion, also email me, guys, and we will get that done together. Okay? Yeah, so let's cover the ammeter display. So I will do that. So now what I will do, I will cover the ammeter display. So we don't need it right now since we have this ammeter. But what I would like you to do, guys, I would like you to figure out this number that will appear here. So what I will do, I will change randomly and have, let's say here, I think we have, yeah, I will double check here. Yeah, so the number that we have right here, guys, we have 2.7 from the galvanometer. So 2.7 from the galvanometer. What I would like you guys to do, I would like you guys to figure out the actual ammeter reading using this ammeter that we built together and tested together. Great, so 2.7. I will add you another point. I will add you another point, guys. Let's go to 3.4. Yes. And then you have 3.4. So the 3.4 is the galvanometer reading. What do you need to do, guys? You need to use the standard equation that you get from plotting the current versus the galvanometer readings. And this equation can be used to figure out the current. Yeah, so you have two readings from the galvanometer. You have 2.7 and 3.4. So try to figure out the current, guys. So this is part number 3. We are done with part number 3, and actually we are done with the whole lab for today. So I would like to thank you guys, and I know that we still didn't cover the theoretical part of this experiment. So that's why, guys, I will post a note, and I will try to explain this note before I post it. And I would like to ask you guys to email me if you have any questions. Again, thank you, and see you next lab.